Alright, so in this problem we're going to take a look at how to figure out partial pressures and total pressures of a gas. So we have a 20-liter cylinder at 19 degrees Celsius that's charged with 5 grams each of sulfur dioxide and oxygen gas. What's the partial pressure of each gas? And then once you figure out those, what's the total pressure? So the basic strategy here is this is going to rely on Dalton's law of partial pressure. So we're going to need to find the pressure total by finding the partial pressure of the sulfur dioxide and adding that to the partial pressure of the oxygen gas. Okay, and then in order to do that, we just need to know that the pressure of either of those gases, so the pressure of SO2, will simply be, from the ideal gas law, the moles of SO2 times R times T all over the volume. Alright, so let's go ahead and do that. Okay, so we first need to convert to moles, so we're going to start with 5.0 grams of O2, and that has 1 mole is 32 grams. Okay, so that will give me 0.156 moles of O2. Just going to carry an extra significant figure at this point, and we'll solve that later. And then I'm going to do the same with the SO2, 5.0 grams of SO2. And that is 64.07 grams. Alright, so now we're going to plug them in. So the partial pressure of O2 is going to be equal to the moles of O2 and that nRT over V. So 0.156 moles times R, which is 0.0821 liter atmospheres per mole Kelvin. Okay, and now we need to do the temperature, which is going to be needed to be converted to Kelvin, so 273 plus 19, and we're going to divide that by the 20 liters we're given at the start. Okay, so we calculate this out, and it's going to come to 0.187 atmospheres. Okay, which will round to 0.19 atmospheres because we have two significant figures. So that's the partial pressure of the oxygen right there. For the SO2, we're going to do a similar thing. Right, we just again take nRT over V. In this case, we're going to use our moles of SO2 from up here. Okay, we know what R is. T is the same. V is the same as well. So this one is simply going to plug that through, and we are going to get that the partial pressure of SO2 is equal to 0.0935 atmospheres, which is going to be, with significant figures, equal to 0.094 atmospheres. Alright, so now the final part of this is we need to find the total pressure. So the pressure total, again, remember, is just the sum of the two partial pressures, so it's going to be 0.19 atmospheres plus 0.094 atmospheres. So we put the two of those together, and what we get is 0.28 atmospheres is our total pressure. Okay, so just like a regular gas law problem, you're just going to solve for the pressure of each gas individually, and then because Dalton's law of partial pressure says that you can add the partial pressures to get the total pressure, we add the two together at the end, and there we go.